Hello, my name is Anne-Marie Walters and I'm the Industry Marketing Director at Bentley Systems, focused on the oil, gas, process and resource industries. Today I'm going to talk about the need for open digital twins that support collaboration across the ecosystem so oil and gas companies can accelerate their move towards things like zero carbon emissions. First, what exactly is a digital twin? Well, it comprises both the visual representation of the asset, but also how this asset is changing over time, the fourth dimension. Information into the twin comes from engineering systems, operations systems, and enterprise or IT systems. And to deliver value, the digital twin should have analytics capabilities to focus attention on what really matters and sort through the masses of data to support decision making. Digitalization and digital twins offer great opportunities to improve asset performance and comply with regulations. However, to meet the radical business changes being demanded to become carbon neutral, for example, and to manage aging assets, many of which probably don't have up-to-date asset data, this requires the industry working together and sharing data and information. And while the oil and gas industry has often been at the forefront of using digital technologies, as Gartner points out, significant challenges still remain. Scaling across the enterprise is hard, especially as these new business strategies are driving even more divergence. Oil and gas companies need to identify the technologies that work across their ecosystems and roll them out quickly across their businesses. Interoperability across and between systems is still a challenge. Open systems that support real-time collaboration across the ecosystem has to be the way forward, and cloud-based digital twins definitely offer this, providing you don't lock yourself into one particular vendor solution. And comprehensive engineering creates intelligent assets. I really like that one. Digital twins start with good engineering data, but that data has to be managed and kept up to date through a collaborative ecosystem. In the UK, the government has mandated digital twins to streamline collaboration and reduce the costs of maintaining the country's infrastructure. This chart shows their key principles for digital twins, and central to this is openness. An open ecosystem enables all the data to be brought together easily without the need for expensive interfaces to be written and maintained. It's fundamental for successful digital transformation. And at Bentley, we focus on tools that design, build, operate infrastructure assets and offer many engineering tools across all the different types of infrastructure, be they bridges, buildings, plants, offshore assets, etc., and across the entire asset lifecycle. We're creating digital twin solutions for some of these industries, like in the process industries, plant site, but we recognise it is not possible for us to create all the solutions for all the needs. We recognise the need for an open ecosystem of developers that can use a common digital twin environment to create the solutions that fill all the gaps. With our expertise providing engineering solutions that work across many disciplines and track changes across these complex engineering tools, we've developed a cloud-based federated data approach to provide a common digital twin framework via what we call the iTwin platform. This platform not only pulls data in from the CAD, GIS, BIM systems, but also supports what we call reality data. That is the capture of existing assets and their conditions from cameras and laser scans. And iTwin.js, that provides the definitions and formats of this complex data and on which the applications are built, is part of the iTwin platform. And iTwin.js is an open source library, and that commits us to supporting an open ecosystem. Here is the architecture of the digital twin platform for those of you who want this kind of detail. It runs on the Microsoft Azure cloud platform, which offers the best security for protecting your data. The platform synchronizes engineering data from multiple sources, manages and tracks changes, provides game-level visualization capabilities via web browsers, and integrates with enterprise systems and operations systems, and also offers analytics capabilities. As mentioned, Bentley is developing solutions like PlantSight for the process industries on top of this architecture that embeds industry standards and enables organisations to get quickly up and running with digital twins. But with such an open approach, organisations and partners can actually build their own solutions as well. So an open ecosystem ecosystem, you get the best of both worlds, both buy and build options. Out of the box, here are the formats that are currently supported by the iTwin platform via what we call bridges. More are being added every day, and since the iTwin JS format is open source, anyone can really build their own bridges. So where is this open approach to digital twins really being used today? I have 3 examples in the oil and gas industry to talk about, but this first example from the telecoms industry represents what we believe is the widespread future for all asset types. The telecoms industry is urgently demanding digital twins, not for experimentation or through limited pilots, but in production for their full fleet of assets to ensure safety, quality and compliance as they competitively increase capacity and utilisation for the 5G fit-out race. Bentley is learning a lot from this industry regards how to automate the creation of digital twins of existing assets, how to provide digital workflows that speed up things like their fit-out decision-making processes without sending people up towers, and to embed industry standards and support a collaborative open ecosystem. Over the past 5 years or so, we've learned how to capture a really good reality model from drones, how to automatically identify assets, and then how to automatically identify conditions such as rust in this example, and link this with reporting tools and reporting and tools that draw engineers' attentions to the most severe issues. This recent announcement illustrates how Bentley will invest in an open ecosystem in this joint venture with partners to develop something called Open Tower IQ for the telecoms industry. The ownership and management of communications towers has been rapidly consolidated into global or regional specialised firms who are often publicly traded towercos. The market is demanding they add 5G capacity to existing towers, which is in turn demanding a digital twin solution that can be rapidly deployed across both the capital programs and the operations of literally thousands of assets for every towerco. This competitive solution now being funded jointly by ourselves and partners is being stress tested in live adoption for infrastructure digital twins of the world's telecoms towers. Now to my first oil and gas example. BP has been using Bentley's technology for many years with their capital projects to enable collaboration between their contractors and manage the handover of accurate, up-to-date information from projects to operations. This example from Oman shows the benefits to operations of having up-to-date engineering information in a central information store based on the Azure cloud. With the combination of a standard approach to information structuring and the open approach of federated data sharing, BP has managed to scale this across all their upstream projects and deliver benefits like this across all their assets. This has also given them a solid foundation of up-to-date information and data on which they can improve reliability and asset performance, as well as driving out inefficiencies in their capital projects processes. This next use case focuses on a large project based in the northeast of the USA. Originally, they started using context capture on a weekly basis to create a complete reality mesh of the site. This enabled everyone to have a shared view of real-time progress of the project, to assess site conditions and act as an aid to the construction planning process. It delivered all of these initial benefits, but it was quickly realised that the real-time reality model could be used for much more. They started using it to assess flood conditions and ponding after a weather condition, and are using it now to assess safety conditions. They're also building this digital twin so that they know exactly what they have where, especially underground, for the during operations. The last most recent example is Shell Deepwater. In order to help Shell improve their conceptual and detailed planning and streamline their capital projects process and provide an open ecosystem with which they can collaborate with their contractors and equipment suppliers, Shell is using the iTwin technology to deliver digital twins of their assets through the utilization of this technology, accelerate the time to first oil for every subsea tieback project they're doing. You may have heard from Futuron yesterday in this session. We're partnered with them, with Shell Deepwater. This AVI shows how their subsea layout tools are pulling information from other systems to plan and compare the costs of compare the costs and also assess the engineering difficulties for various options. Bentley is partnering with Futuron, an innovative Norwegian firm that specialises in subsea planning, to combine our respective open cloud platforms and help to accelerate the delivery of subsea digital twins. And here you'll see the concept comparing side of the tools pulling this all together. I hope my explanation and examples have shown how an open approach to digital twins is essential to enabling the entire ecosystem to collaborate and hence accelerate developments that will sustain the oil and gas industry. Thank you. I think we have a minute or two for questions, and I would point you at our workshop session at 1 p.m. today if you want to find out more and see the technology in action with a live demonstration. Thank you.
Thanks, Anne. Yes, just to reaffirm what you said, Bentley do have a wonderful breakout session at 1 p.m. today, which is titled the same as what Anne was talking about. So they're going to be a lot more expansive on that topic, called Collaborate, Accelerate, Sustain. And we have a couple of minutes for some questions. Thanks you very much for that presentation. I really love the work that you're doing with Future, and obviously they're another silver sponsor for the event. So it's great to see you guys working together. And I similarly love the work you're doing with Shell Deepwater. I'm quite familiar with that particular initiative as well, with some of our guys we're working with. From our side, how does a digital twin environment work with the engineering systems EPCs already use?
Sure. We get that question a lot. One of the benefits of the cloud environment and the open ecosystem is we've built bridges, and other people, as I mentioned before, can build bridges that reach into those systems on a real-time basis and pull that information back into the digital twin environment so that everybody can see what's going on in real time and share that information. So it sounds a bit scary in a way, because the industry is very used to delivering deliverables, if you like, but we're seeing a much greater need for real-time collaboration between the engineering firms themselves, but also with their supply chain and with their owner partners. The pandemic has accelerated this as well in terms of everybody working remotely. So what we're actually seeing is that need to openly share data between the engineering systems that the EPCs are using and the digital twin environment, so that everybody can collaborate and make decisions together much faster, basically. And like I said, you've got these bridges, basically. Yep. Sorry, Adam.
Yeah. No. It's interesting what you say about the data, because it was mentioned yesterday a few times about what state do you need your data in before you embark on this type of journey. Another big issue, obviously, is out-of-date asset information. So do I have to get all my data or asset data in order before benefiting from these digital twins or not? Or is there a middle ground?
There certainly is. I mean, one of the biggest challenges that face the industry is existing assets with existing probably out-of-date data, because it's been so hard to keep the engineering information up to date, which has typically been locked into the engineering systems. What we're seeing is people are bringing are getting access to the information, bringing it into a cloud-based digital twin environment. Then, if you've got tools that make it easy for people to identify data that's out of date and feed that back, and then have a good environment that manages that change, you can actually use the digital twin environment to start your digital twin progress and gradually get that data up to date, basically. In fact, the deep water, the Shell Deepwater example I spoke about initially, they implemented that. Well, they're implementing the digital twin environment in their conceptual subsea planning phase. They've realised they need an environment to keep the information up to date, so they've latterly adopted a change management environment and an asset management environment to support this their digital twin approach, and ensure that the data is kept up to date throughout the capital project process and into operations. So you don't need to have the data perfect to start with. You can absolutely improve it and adjust it, if you like, and keep it up to date as long as the data is being used and as long as people trust that information. So you do need to have a good, solid management foundation to support that. But you can start exposing the data via web browsers in a digital twin environment and having those tools, as I mentioned, to keep it up to date and manage the change is a really good way of improving the quality of your data.